Welcome back everyone to another episode of the Doom series, and in this video we are going to learn about loading multiple palettes from the WORD file and displaying that in our OpenGL engine. Alright guys, so before we begin with the actual topic of today's video, we are going to look into a couple of changes in the input.h and input.c files. So inside of input.h, what you can see is that I have added a new function which is button just pressed. So this button, this will return, this is button pressed function returns true as long as the button is being pressed, while this will return true only if the button has been pressed on this current update. And we've also got a function called input tick here. Now what we do basically inside of input.c is that we have got another array here called previous buttons. Now when the if button just pressed is called, then we make sure that currently the button is pressed, and we also make sure that the button was not previously pressed, which means that the button was, well, just pressed. And if that's true, then we return true, otherwise we return false. Now inside of the input tick function, we just copy the previous functions in the buttons into the previous buttons, and that's pretty much all we do. So let me go ahead and open up main.c here, and what you can see is that inside of this we first of all update our input tick, then we poll all of the events and set the frame rate and everything, and then we call engine update, and then we clear the render, then we render the engine and update the buffers and all of that. So this is basically the way we do this. So I'm going to go ahead and open up my palette.h header file. So first of all, actually let's open up our word.h header file. Now inside of this you can see we basically have changed the word read playpal function, because playpal lump inside of Doom consists actually of a lot of palettes. It consists of 14 palettes in the original game, and we are basically gonna load all of them. So we have got a size and security pointer to a number, just like we have got all of these other ones. It's basically the same basic outline. So let's go ahead and open up the palette, actually not palette, the word.c file. So I'm going to open up word.c, and inside of this what we do for that function is that we only change a couple of things. So first of all, we return null if the playable index is less than 0, and then we set the size. We create a temporary variable here called palette size, just so that accessing it a bit easier. So each palette is equal to number of colors multiplied by 3 bytes. So number of colors is 256, so it's equal to around 768 bytes around. So then we set the number of palettes to the size of this lump divided by the size of one palette, and then we allocate the memory for those palettes by using malloc here, and then we loop over each of the palettes, and then we copy the palette data. The way we do this is that we copy as many bytes as in palette size here, and we get the word lumps data, and depending on the current index we add the value of the current index multiplied by the palette size to it, so that we access the correct palette. So all of the palettes are stored continuously in the playpal lump without any special things in between. We just do that, and in the end we return the palettes. So this is all pretty basic stuff, and now I'm going to go ahead and look into palette.h, which is a bit different, which is that inside of this function, instead of having a palette generate texture, we now have a palettes generate texture, which also takes a numerical argument for the actual number of palettes. And now let's go under palette.c to see how we do this. What we do is we use a GL texture 1D array, so not a 2D array but instead a 1D array, because this is a palette, and with this we have got all the basic stuff here just like you would expect, and we use GL text image 2D and we pass our palettes directly. Now you might be saying why we do that. Actually the reason behind that is pretty simple. As we can see, our palette is number of colors on the x-axis, and on the actual number of elements in the array we have got the num value here. So the way we set this to palettes is that our palettes, as you can see, if I open palette.h, you can see our palette only consists of the data and nothing else. So basically this means that we can go ahead and pass the palettes here directly, and that should automatically work without having to do any complex stuff. So yeah guys, that's pretty simple basically. So now let's go ahead and go under engine.c to see how this is actually used. So inside of engine.c, well, first of all we'll take a look at render.h, because that also needs to be changed. We basically added a new function here called render set palette index to set the current index for the palette that we want to use. And you can see that here vertex here stays the same, while for the fragment shader we now change our palette to be basically a sampler 1D array instead of a sampler, just a sampler 1D, and we've also got a uniform int here for the palette index. Now for setting the each time we need to fetch the color from the palette. The way we do this is that we have got we use an I vec2, so we construct an integer vector2 with the texture index that we have got, and we just pass the palette index for the other value. We basically do that in all three cases. So with that, we now go ahead and have another GL unit here called palette index location, which represents a uniform location for the palette index, and we use this inside of our palette set index, so to actually set that location. And for the render set palette texture, now we use GL texture 1D array instead of just GL texture 1D. And of course, in initialization, we must make sure to initialize our palette index location as well, and yeah, everything else basically stays the same. So yeah, that's all pretty awesome. Now let's look at engine.c. So in here I have rearranged some variables and used some unused variables, and basically we have also removed the wall texture and the flat texture array, since that is just set in the main init functions. We don't actually need to store those, but we do need to store the number of flats, the number of wall textures, and the number of palettes, along with the wall texture info and wall max coordinates and all the other stuff, as you can see. So now we have got our engine initialize function here. Now inside of this we get the array of palettes from the play pal, and then we set a palette texture to this value. And in the end, what we do is where we are setting our wall texture and flat texture, we also set the palette texture to this palette texture that we have generated. Now in the update function here, I've just temporarily defined a palette index here, which is set to 0 by default, and we use the just press to see. If it's O, then we decrement the palette index, else we set it to U. If it's P, then we increment it, and then we make sure that it's clamped to the correct range here. We don't want that to go wrong, so that's make sure that we don't go out of bounds. And then inside of the engine render function, we use render set palette index to set this to the current palette. And apart from that, there is literally no other change, and I can run make right now. You can see by default it looks exactly the same, there's no other change. But if I press P, you can see that it gets slightly red, because well, palettes in Doom are used to kind of simulate different effects and stuff. So when you're taking damage, we use the red one. So if I do P again, you can see it gets more red. If I do P again, it gets even more red, and up till the index 8 it will keep getting red. And here it's at the maximum intensity of red, and you can see everything in our scene is completely red. And after that, well, there's another intensity of red, which is very large, and after that you can see we start to get the yellow intensity, so it gets more and more yellow. This effect is used when we are picking up some objects. You might notice in the original Doom, when you pick up something, the screen flashes yellow kind of. So this is used for that effect. And in the end, we have got green, which is used when we pick up the hazardous environment suit or whatever that's called. And yeah, this basically means that all the palettes are working, and this is the last palette, and we can go back to the start for the original default palette, which everything is used to render. So yeah guys, this is going to be pretty much it for this video, and I'll see you in the next one, in which we are going to improve our render more and fix other problems and add more features, because there are a lot of other features you could add to this render, and we are going to do that in the future video. So make sure you don't miss that, and subscribe as well, and I'll see you in the next video. Make sure to share this video with other people, and bye.